Hello everyone. Hi, this is Supply Chain Management and Logistics. In the last class, after I finished about the cycle inventory, I began to talk about another kind of inventory that is safety stock. I also provide you some of the basic information about the statistics. Today, I'm going to start with these statistics. Let me get to my note. Okay, so there's a reason why that I brought the statistics because when we talk about the safety stock, the reason why we have a safety stock because of uncertainty of demand and supply. So that's why there's something that we have to that the tools to the describe the uncertainty in a way. Okay, so there's uncertainty here. So in order to describe this uncertainty, I'm going to use the probability. In particular, this probability is not coming from anywhere. It's coming from the specific, the probability, the distribution. Probably that's the only way we can analyze this uncertainty. So that's why I brought this, the basic, the knowledge that of the statistics here. So you remember that I specify that is one of the many, the probability distribution, that is the normal distribution. The reason why that we use this normal distribution very frequently because of so-called central limit theorem. So because of that, we're going to use the normal distribution to describe the uncertainty of demand here, okay? So talking about normal distribution, normally let's say xi, this is just a series of the random variable can follow in the normal distribution with the mean is a mu and sigma square is the variance. And also I already mentioned that is because it's going to be hard, not impossible. It is very hard to calculate any probability under the normal distribution. That's why we go through the so-called standardization first. That is, standardization process is very simple. Using this the formula, just the xi minus mu and divided by sigma. That is, let's say this is the zi, another kind of the random variable. This process is so-called standardization. And then with this, the standardization process, this G here is the following at this time is a standard normal distribution, okay? So that is, normal distribution with a mean is 0 and standard deviation is 1. The variance is also 1, okay? And also the reason why we have to change the switch from the normal distribution to the standard normal distribution because once you have a standard normal distribution, it's easy to get any probability under the standard normal distribution. How? By using so-called standard normal distribution table. So here I'm going to show that this table, this is so popular, this standard normal distribution table. You can find in any the statistics, the textbook, okay? Is one of the appendix normally, okay? So what is this standard normal distribution? That by using this table, okay, you can get any probability under standard normal distribution. So let me show you how we can use this table to get the specific probability under the standard normal distribution. Okay. So where you look at this, the standard normal distribution table is, first of all, you have to take a look at this, the graph here, this graph. Normally it located under or on the upper, the right hand position here on this table. Okay. So what does it look like? Yeah, it's very similar to that, the shape of the normal distribution. It's a berry shape. In fact, this is the shape of a standard normal distribution on the table. Okay. So this is a berry shape again, and also is a symmetry in the middle of a mu. What is a mu here is a 0 because it's a standard normal distribution. And of course, the variance in the standard deviation is a 1. Okay. And also the reason why we have to look at this graph first when we to read this table is because normally there is two different versions of a standard normal distribution table. Okay. This is just one of them. That is, when you take a look at this graph, this shaded area is starting with a 0. But on the other hand, if you take a look at another kind of standard normal distribution, the shaded area on the graph started with either minus infinite, not a 0. That is another kind of very different, the standard normal distribution table. That is, in this table, it started with 0, this shaded area. So that means what? No matter what kind of probability is inside of here, okay, it will show you the specific probability starting with always 0, okay, 0 to until g, a specific, the g value. That probability indicated inside of this table, okay? On the other hand, if you have another version of a standard normal distribution table, the shaded area will start it from the minus infinite, okay? That means what? There's any, the probability inside of that table indicating always probability starting with the minus infinite instead of a 0, okay? So what's the difference? Actually, difference is very simple. What is that? Is that just the shade, that area under the curve between minus infinite to the 0. So what is it? Yeah, just half of 1. Then what is that? 0.5, okay? So when you take a look at this table without even the graph, if you take a look at the very first this probability, that means what? It's starting from the 0 to the 0. Okay, so the probability between the 0 and the 0, that is just a simply 0. So you can, if you see that the probability on this table is a 0, that means this the probable standard motion table that tells you the probability starting from the 0. But on the other hand, in another version, starting from the minus infinite, then what kind of number you will find on this position? Yeah, is a between the minus infinite to the 0. So that means is a 0.5. Okay. So either is a 0 or 0.5. That way you can find this easily understand. That is, this table starting from the 0 or minus infinite, even without looking at the graph. Okay. So let me tell you how we read this, the table and the catch, the specific probability that using this table. Okay. The first of all, if you take a look at the first column outside of this table, okay, that is starting from the 0 0.0, 0 0.1, 0 0.2, this is indicating that is a G value, okay, G value up to the first digit below the decimal point. But what about the second digit of the decimal, below the decimal point about the G? That is top portion of this table, this one, okay? So that's why you have only 0 0.0 until the first digit below the decimal point. You have the 0, 1, 2, 3, 4, like the second digit below the decimal point, okay? So for example, let's say, okay, if you wanted to get the probability, like what is the probability that G is following the standard normal distribution, and the G value is between the G value is 0.56, okay? So what you want to get is, let me go back to the memo here. So let's say the G is following the normal standard normal distribution, and you want to get the probability that is G is starting from the 0 to the 0.56. You want to get the probability by using this table. Then how can I get that? Go back to the table. That is, first of all, you have to cover the first digit below the decimal point. So what is that? 0.5, 0.5 here. And then what about the second digit? The 6. So 0.06. So you have to find the cross line of this 0.05, this the line, and 0.06 from the vertical line. Okay. So what is that? This is a probability of the Z is between the 0 to 0.56. Okay. So it's as I see, is a 0.2123. So all I have to just write down here, 0.2123. Okay, just make sure that you have the right one. 0.2123. So that way you can easily get the probability here. Okay, but on the other hand, what about if I have some probability, still the G is following the standard normal distribution, but at this time, this G is not starting from the 0, is anything, any other thing. Then probably you can say that you're in trouble. Why? Because in a table showing only the probability starting from the 0, okay? Especially is up to the positive side, not a negative side. Is that means that we cannot get the probability that G has a negative value, negative area? No. In fact, under the standard normal distribution table, under the standard normal distribution, the negative is always possible, right? Because just like a normal distribution, standard normal distribution can take the number between minus infinite to the plus infinite. Okay. So question is, how can I get the probability that's starting with other than the 0, especially in the negative area? Okay. So let me have some example here to show you how to get the probability under the special situation, such as, let's say, if you have the G still again is following the standard normal distribution, and question number 1, you want to get this specific probability. Let's say the G is greater than the 2.35. So what's the answer? Okay. You might find that this is awkward, right? Again, it's not starting from the 0. This is not less than a certain G. This is a greater than 2.35. Okay. But on the other hand, okay, if you just take a look at the specific nature of this standard normal distribution, as I explained before, okay, then by using that, we can easily get the particular probability, even though just using the table, okay? So normally the way I get the probability under the standard normal distribution by using the table, that is, I draw the graph. So here's that. From the minus infinite to the plus infinite, of course, the standard normal distribution look like just a bear shape, okay? It doesn't have to crack in scale. In the middle is a 0, mean, okay? So what I want to get here is that what's the probability G is greater than 2.35, okay? So where's a 2.35? Of course, it's greater than the 0. So probably approximately here, 2.35. Okay, so as I said in the previous class, just like a normal distribution, standard normal distribution is another kind of the continuous probability distribution, always indicated as an interval. Okay, specifically, just like a normal distribution, standard normal distribution, the probability indicated by the area under the curve between the interval. Okay, so if I have to get the particular probability under the standard normal distribution, then what should I do is just here 2.35, and in the left hand side or right hand side, yeah, it's greater than equal to. So this side, this shaded area become the probability I want to get. Okay, so how can I do that? That is, it's like you playing with a jigsaw puzzle, right? Have you ever played with a jigsaw puzzle before? Okay, you try to fit the pieces, small pieces, and make the big picture in the end. Okay, so here the idea is anyhow I know I can get the probability from starting from the 0. So because of that, just playing with this area, just putting in a half, just divide in a half. And from now on, I consider only this positive side, right-hand side of this, the half of this graph, okay? And then all I have to do to get this shaded area is from the half that just remove this empty area, okay? So inner the equation, that is, this is exactly same with what? The probability that the G is between the 0 and my plus infinite. There's a half of that, okay, half of this entire, the area under the curve, and minus the probability from the starting from the 0 to the 2.35. So empty area here, okay? And then we can get this shaded area. So here, continue. So what is the probability that G is between the 0 to the plus infinite? Even without looking at the table, you already know. What is that? It's a symmetric nature, right? So that's why half of this entire area under the curve is 1. I'm sorry, half is 0.5, okay? So it's a 0.5, okay? And then minus, what about the probability between the 0 to the 2.35? Yeah, we can get this probability by using the table, okay? So what I have to do is go to the table, and there is a 2.3 and move up. 2.3 is here, 2.3. And what about the 5, the second digit below the decimal point, is here, okay? So if you just having the cross line, then is here, is 0.4906, okay? That's the probability I can get from the table, okay? So here's that 0.4906, okay? And then just a simple calculations, that is a 0.0094. That's it, okay? So that way, even though I cannot get this probability from the questions, the directory from the table, but still by using the nature, the basic nature of this standard normal distribution, I can easily calculate the probability, okay? Let's take another case, that is question number 2. What about the G is less than minus 1.96? Again, this is, you cannot get this probability directly from the table, okay? Even though it's less than a 0, it's not starting from it's 0, okay? And also, what about this one? It's a negative value. if you take a look at the table, you are not able to find any negative value here. Okay, so what should I do? Again, try not to be confused. I always draw the graph, okay, from the minus infinite plus infinite, okay, in the middle is 0. This is a standard normalization, the graph, and that I'm trying to figure out what's the specific area I'm looking at when I try to get this probability, okay? So it's starting from the minus infinite and then up to the minus 1.96, okay? So in fact, this is a area, this shaded area is the probability I want to get, okay? So what's the idea? Yeah, again, this is symmetry, okay? Symmetry means what? If you put it in half in the middle of the 0, okay, then actually this from probability from the area between the minus infinite to the minus 1.96 is the exactly same with what? Plus 1.96 up to the plus infinite. Okay, this is twins. Okay, I'm sorry, this my graph is not exactly correct. Okay, but on the other hand, you get the idea, right? Okay, this side and this side will be exactly same. Why? Because it's symmetric. Okay, in the middle of 0. Okay, so that's why here I can say the probability is that G is less than minus 1.96 is exactly same with the G is greater than plus 1.96. Okay. So once you get this, then you can use you can apply the same idea with from the question number 1. Okay. So what should I do? This one is again just the cut in a half, and then just from the entire half side of the left hand or right hand side, you just have to remove this empty space. Okay, so what is that? Is a again probability that is from the 0 to the plus infinite and positive side of half and minus between 0 to 1.96. Okay, so first term is the original without even without look at any other thing. Okay, and the minus just a half, and minus, what about this one? Yeah, you can get directly from the table. Okay, now what is the probability that starting from the 0 to the 1.96? Okay, take a look at the table. Where is a 1.96? Yeah, up to the first digit 1.9 here. And then what about 0.6? 0.6 is here. So 1.96 and a 0.6. The cross point is, what is that? 0.4750. Okay, so I have just copy that number. Okay, 0.4750. So that is 0.0250. Okay, so that way I can easily get the answer. And let me have another example, the last one. Okay, the question number 3. What about the probability that the G is between minus 0.23 and 1.45? Okay, so again, I'm trying to draw the graph to figure it out. With specific area, this probability indicated under the graph. So from the minus infinite to the plus infinite, this is the standard normal distribution. And then in the middle is 0. Okay, so this is a specific probability indicating that area between minus 2.23 and 1.45. Area between this interval, these numbers, and under the curve. Okay, so what should I do? Again, just like playing with the jigsaw puzzle. Let's just be using this. This is one of the the two pieces of jigsaw puzzle. Okay, so I'm gonna handle one by one. Is the left hand side and the right hand side in the middle of 0. Okay, so this is shaded area first, and then get this is second area. Okay, so what about, so this is basically when I divide it in the middle of the 0, this is a probability between minus 0.23 and 0 plus, because of this is area, talking about areas, okay? And then 0 to the 1.45, okay? So what about the first term? What should I do? Yeah, again, this is a symmetric nature, okay? So that's why, which area is exactly same with this one? Yeah, another half of this, another side of this one, okay? So it's exactly same with between the 0 to the plus 0.23, okay? And then second term is just, or you have to just write down as it is. I don't have to change at all. Why? Because this is the probability I can get from the directly from the table, okay? So we have both terms that form of a probability you can directly get from the table, okay? So what I have to do, what is the probability of these two probability from the table, okay? So what is that? What is the probability that G is between the 0 to 0.23? Take a look at the table. That is 0.2 and 3 here. So that is 0.0910. Okay, so I have to just copy that number 0.0910. Okay, plus, what about G between the 0 to 1.45? That is, again, 1.4 here. And what about 5 here? So 1.45 and the 5, the cross point is 0.4265. Okay, so I have to just copy that number, 0.4265. So after all, the probability is 0.5175. Okay, so that way we can get the probability by using this table. Once that the probability about the standard normal distribution. So again, that because of a central limit theorem, again, I'm going to use that the normal distribution to indicating the uncertainty of demand. And then in order to calculate the uncertainty by using the probability, okay, I'm gonna use this table, the standard notion table. Once I standardize the original, the normal distribution probability, okay? So that's the overall idea, okay? So let me get to the again, the safety stop. Okay, so here, what I want to get is how can we evaluating the cycle service level given a replenishment policy. Okay. So let's say the cycle service level, one of the indicator of the product availability, that is, this is kind of definition. This is a probability that is the demand during the lead time is less than reorder point. Okay. So when you have a reorder point, that means this particular replenishment policy is just a continuous the review system. Okay. So regarding the continuous review system and another one is periodic review system, okay? We will have a chance to talk about this later in detail, okay? So let's say this is assumption. Demand during the lead time following the normal distribution with the mean is DL and the standard deviation is a sigma L, okay? So this is a mean, this is a variance, okay? Then the way we calculate the average demand during the lead time is just simply the average of demand multiplied by the lead time, okay? And what about sigma L? This is a standard, let me write down, standard deviation of demand during the lead time, okay? That is the sigma D. This is just the demand, the standard deviation of demand during any some time, okay? So it's like a weekly demand, talking about weekly demand, that means what? This is a standard deviation of a demand during a week, okay? So multiply by the L square root of L, okay? That's the way you can calculate the standard deviation of demand during the lead time. Okay, continue. So according to that, the way you calculate cycle service level is the probability the demand during the lead time is less than or equal to the real point. And because of that, the demand during the lead time is a normal distribution. So I would rather use the table to calculate this probability. So what's the process I have to go through first? That is, change this is as the following the probability. This is the probability following the standard normal distribution. Okay, not normal distribution. How come? By using standardization. What is that? Just the real point minus the mean. What is that? Mean is the demand during the lead, average demand during the lead time, and divided by the sigma L, standard deviation. Okay, so that is a standardization process. Okay, then once I get that, let's say that calculation give me a G star. That's some specific number, then I can easily get this probability by using the standard, the normal distribution table. Okay. So let me take an example. Okay. This example from the textbook. Example the 12-2, the page 332. Okay. So given information is the order quantity is the 10,000. This is fixed. And a real point under this system. So we have a real point, that means this is another continuous the review system. Okay, that is 6,000. And lead time is 2 weeks. That means what? Once you place order, you can receive the ordered product 2 weeks later. Okay, and the demand is 2,500 per week. Okay. And then the other information is about the demand, okay? That is, the sigma D is 500, okay? So remember, sigma D means what? Is standard deviation of demand during a certain time period. In this example, because I consider a weekly basis, so that's why this is a 500 is standard deviation of demand in a week, okay? And then is a basis. So that's why here, what I can say is the demand is again, this is there is uncertainty. So we cannot specify the demand as a number, okay? Just like what we did when we talk about the cycle inventory, okay? It's talking about safety stock, okay? That's why we have to handle the uncertainty of a demand, okay? So this is a demand is, at this time is the unknown variable, okay? But anyhow, we have to specify the distribution, okay? Is this demand is coming from, so that's why we're using the normal distribution. Let's say demand is the random number, but it's following the normal distribution with mean is, what is mean? Here is a 2500. And what about the standard deviations is a 500. So variance is 500 square. Okay, so that's it. Okay. And then with this information, we can calculate the cycle service level. But before that, we need to calculate this first, the mean of demand during the lead time. That is just the mean of demand multiplied by lead time. That is 2500 multiplied by 2 give me a 5000. And what about the standard deviation of demand during the lead time? It's just the following the formulas I already gave you. That is the sigma d multiplied by square root of L. That is what I have just plug the numbers here. 500 multiplied by the square root of 2. Okay, that is 707. Okay, now I'm ready to calculate the cycle service level. So what is the cycle service level? According to the formula I already gave you, that is the probability is demand during the lead time. This is not any demand. This is demand on during the lead time. Is less than or equal to real point. So according to that, is the demand during the lead time is less than, what is the real point? Real point is already given, so it's a 6000. Okay. Then, because the demand during the lead time still following the normal distribution, okay, in order to get the specific this probability, I need to standardize it, okay, to use the table. So what is that? The probability of now is become the G, because G following the standard normal distribution, not a normal distribution. So that is real point minus the demand during the average demand during the lead time, and divided by the standard deviation of the demand during the lead time, the sigma L. Okay. So make a space here. That is, the G is less than 6000 minus the mean of demand during the lead time is, I already have 5000, and divided by, what about the standard deviation of demand during the lead time? I already get that, 707. So if you calculate that, that becomes G is less than 1.41. Okay. So how can I get this probability? Yeah, from the table. Okay. So take a look at the table. 1.41 is 1.4 here. And where's 1? Is 1 is here. So 1.4 and 0.01 is cross point is 0.4207. So that is 0.4207. Is that all? Is that 42% cycle service level? No, no. You missed something. Okay, what is that? Yeah, just the standard normal motion table. okay, we have is starting from the 0, not a minus infinite. But on the other hand, the original probability we try to get is not starting from the 0, starting from the minus infinite, okay? So here, we missed something else. What is that? 0.5. So that is a 0.9207, okay? So this is the cycle service level is 92%, okay? So where you interpret this outcome is, because this is cycle service level, in 92% of the replenishment cycle. As I said, when you have a cycle, whenever you have a cycle, it's a time. The company can supply all demand from available inventory. Okay. In other words, that this company can provide other services to the customer. Okay. That much the company has enough amount of inventory in that in 90%, 92% of the time period. Okay. So it's like what is if you consider that the full period is the 100 hour, okay, then this company can provide that the fulfill all the orders from the customer in any customers, okay, during that 92 hours, okay, then much sufficient the inventory this company has right now, okay? So that means there's the meaning of 92% of a cycle service level, okay? And then next, let me consider another way to describe the product availability, that is evaluating the fee rate instead of the cycle service level given a replenishment policy. The fee rate, the way you measure the fee rate, this is FR, is 1 minus ESC and divided by Q. Okay. So in other words, that is a Q minus ESC divided by Q. Q is just the lot size, the order quantity. Okay. And what about ESC? ESC is expected shortage per replenishment cycle. Okay. So for example, let's say X is the demand. I'm sorry. During the daytime is following the normal distribution where the mean is a DL and sigma L is a standard deviation. Okay. It's just assumption. And then also are following the continuous the review system. Then the way you calculate the expected shortage per cycle is the X minus real point and multiplied by Fx and a dx, and the integral between the minus, I'm sorry, not a minus, is x equal to the real point to the infinite. Okay, so this is the integral. Differential equations, that is that it's the opposite of derivatives. Okay, so that means what is because this fx is a continuous the function, continuous probability distribution, as I said, normal distribution. That is because of that it have to use the integral instead of a summum. Okay, and then here let fx be the density function of the demand distribution during the lead time. Okay. In fact, there's a shorter version of this calculating the expected shortage per cycle. That is, ESC is minus SS. Let me just write down and then explain later. Okay, 1 minus Fs and SS divided by sigma L and close the bracket plus the sigma L multiplied by Fs and SS divided by sigma L. So here let Fs be the standard normal cumulative the distribution and then Fs be the standard normal density the function. By the way, let me explain about the difference between the cumulative distribution function and the density function. That is, in the statistics, there's a two way you can describe the specific probability using the function. That is, the probability, the density function. The another one is cumulative distribution function. The difference is simple. If the probability density function indicating the probability of a specific x value, then let's say the cumulative distribution is not just the single event's probability, it's a cumulative one, normally indicating f, the capital Fx instead of a small fx. That is, the probability, let's say x is less than this x. Okay, so it's cumulative. It's not only single shot. Okay, so it depends on whether it's a continuous or the discrete probability. If it's discrete one, this cumulative distribution function is just a what? Fx and combine sum up with x is less than x, small x, up to the small x. Okay, or if this is a case of discrete. In case it's continuous, then you have to use the integral from the minus infinity to the this one. I'm sorry, this should be the big one. Okay, and this is a small one. Okay, if this is a continuous probability. So that's the difference. Okay. And then of course here is SS is just the safety stock. It looks complicated, but it's not. So let me take an example. Directly go to the example showing how we can use this formula to calculate the fill rate. Okay. So this example from the textbook, another example is 12-3, page 333. Then given information is the Q is 10,000. That means every time you order 10,000 units. The demand during the due time, average demand during the due time is 5,000. And standard deviation of demand during the due time is 707, just like a previous example, okay? And then what about the safety stock? Real point minus demand during the due time is 6,000 minus 5,000 is 10,000, okay? And then expected Shortchi per cycle is just following the formula, just plug the numbers here, minus 1,000 and open the bracket and 1 minus fs. And this is not a multiplication, this is a function, the cumulative, the normal distribution function. No, that is 10,000 divided by 707. I just plug the numbers from the formula I already gave you, okay? Plus 707 and multiply by fs. Fs is a what? Standard normalization density function, okay? It is 1,000 divided by 707, okay? Then what should I do is I need to know that what's the formula for the normal density function, normal density function formula, okay? So here, fs x equal to 1 minus, this is a little complicated, and square root of 2 pi and multiply by exponential of minus x squared divided by 2. Okay. So here, of course, the pi is, you can use a pi you use a pi to calculate the area of a circle. This is a pi is normally 3.14159 and continue. But let me just stop here. And what about exponential? Exponential is, this is about the logarithm. That is so-called exponential constant. That is the first power of exponential is 2.7183. This is so-called exponential constant. Okay. So when you say that exponential x power of exponential, that is y, then according to the logarithm, that is, this is a natural log of y equal to x, the same relationship, okay? This is a natural law. So by the way, such as if you wanted to calculate the exponential of, want to calculate the exponential of some x, then all I have to do is just the x power of the exponential constant, 2.7183, that way, okay? So go back to the formula to calculate the fill rate. That is, all I have to do is just using these other formulas that is ESC, the expected shortage per cycle is what? The first part is a minus 80 plus the second term is 104.42. So after all, that become 24.42. Okay. And then continue according to the formula to calculate the feed rate is just the Q minus expected shortage per cycle divided by Q. So I have to just plug the numbers. The Q is 10,000 minus 24.42 divided by 10,000. Then if you calculate that, that is 0.9976. Okay. So here's that. The way you interpret this, the feed rate is 99.75% of the demand is filled from the inventory in the stock. Okay, that's the end of the measuring the feed rate, okay, from the example, okay? So I think it's a good time to stop. So let me stop here and continue with this next time, okay? So that's it for today. See you next time. Bye.